All right, good morning, everybody. Welcome back to CSE224. So, how are people doing today?
Good, how are you?
Pretty good, thanks. All right, so looks like a bunch of people are still coming in, but we're going to go ahead and get started anyway. Um, Hopefully people have tried to log into the Linux server at this point. Most people have tried and succeeded. If you haven't tried logging in yet, you need to do that right now. And you need to get an email to me immediately if you're having trouble with the login. Because you have homework due tomorrow morning at 8, which requires you to log in and do a couple of things on the server. And we're going to start working in Linux today, so ideally during lecture you're logged into the server in another window on your computer, so that you can play along and answer questions and things like that. So let me start off with a show of hands. How many people currently have access to and are using a Linux-based machine? So something that's just running Linux. All right, looks like about 5 people. Um, so yeah, that was my next question. How many people are running a Mac with OS X? How many people are running on a Raspberry Pi? That's awesome. How many people know about Raspberry Pi? All right, you got to go do some Googling on Raspberry Pis. Um, cool, lots of hands. Yeah, these things came out a number of years ago, and they were advertised as a credit card sized computer, and it was a little unthinkable at the time, and I stayed up with a good chunk of the planet, I think, waiting for the website to open in Europe, in England, and the website crashed as soon as it opened for orders and stuff. But I got my Pi a few months later, and it is a credit card sized Linux machine. It's a full blown computer. It's pretty powerful. It's multi core. The Pi 4 has built-in Wi-Fi. It's got USB 3.0, 2 HDMI outputs for dual display, and it typically runs a distro of Linux. And they're relatively inexpensive. The Pi Zero was actually a $5 standalone computer. You just had to hook up, keyboard, mouse, display, things like that. But it's a really fun and pretty low cost way to get into doing some Unix maintenance, working as administrator and so on and so forth. And these units, they're chock full of pins for connecting I/O devices to, switches and LEDs and motors and sensors and all kinds of things. Um, and anyway, they're really fun to play with as computer science students, engineering students. They're one of the coolest things to come along in quite a while. Um, and it's your system, so if you break it, you can just reflash the hard drive, which is a micro SD card, and start over again. But you make accounts, you're running as the root user, all this kind of stuff. Highly recommend if you're inclined. Try to pick one up and play around with it. Someone says they have a little Raspberry Pi emulator with a Zero. That's cool. Um, all right, so if you do not have a Linux machine or OS X or a Raspberry Pi, or even maybe if you have OS X, I strongly recommend downloading and installing VirtualBox. And this is a system. It's a program that runs on Windows, it runs on OS X, but it basically emulates a full-blown x86 machine. And on that virtual machine, you can do things like install other operating systems, for example, Linux. Windows has a Linux subsystem built in. I have not found a lot of happiness with it, and I've had students who have tried to use it in the past and run into things where it's not quite right, it doesn't quite play nicely with other parts of their system, and so on. So I've tried it a few times. I kind of avoid it now. If you do VirtualBox and you install Ubuntu on top of that, you've got a full-blown Linux system to do with as you wish. And let me show you the effect of this. So this is VirtualBox. It's freeware. It comes from Oracle, and I've already installed a downloaded version of Xubuntu. And if I hit the start button, this basically boots up Linux. And so this is the splash screen you normally see when you fire up hardware. And there you go. There's my Linux environment, and I can hit Control Alt T to bring up a terminal window, and I can type in Linux commands. And I can see that I've got 134 tasks running on this virtual machine right now. And it's beautiful, and it's fast. It actually runs faster in some cases than the native underlying operating system, if your operating system is Windows, for example. Okay, someone's running Zoom in VirtualBox. That's pretty awesome. Yeah, it's pretty solid. It interacts with the network, right? So from here I can, ping Google, and it's piggybacking on top of the network of my underlying operating system. But it thinks that it's got a virtual device with IP address 10.0.2.15, and that's just synthesized, right? Emulated in software. I strongly recommend doing this, because once you do this, you have a Unix environment, even if it's Windows underneath. You run this program, click on the icon, right, hit the start button, and you've got this whole environment. But you can still click out of that, and you've got your plain old desktop with whatever you're running natively. So if you go to, so let me shut this down. I'll let it shut down in the background. So if you go to the playlist, let me bring this up on another window. If you go to the YouTube channel that's linked in Canvas, this second video on here, Intro to Using VirtualBox and Xubuntu, talks you through the steps of downloading it, installing it, putting in the operating system on top, and some basic use cases. Give it a try, right? I don't see any downside to using it, and your experience in this course and in the sequence of courses will be smoother if you're actually working and living in a Unix environment. And you don't have to get rid of Windows, you don't have to dual boot or do anything strange like that. It's a big program that pretends that you've got a Linux machine. So go through that video and try to do that download, and let me know if you run into issues. Okay, I've not done this in the class before. I usually have people use Cygwin, which is a not quite as complete Linux replacement. But I want to try to get everybody running in Linux this term. So mess around with that. All right, so let's talk about Linux basics. And I know that you use, the CTEX server in 121, So you've got some experience with Linux already. But let's go through some stuff from start to finish and all get on the same page. So the preferred way to get in and out of the server is to use the SSH command. And this is documented in the how-to on Canvas. That how-to is a good guide to refer to, by the way. It's only a few pages, but it takes you through logging in to the server, doing basic things like changing your password and so on, plus some introductory Unix commands. So, so with SSH, I'm going to do SSH username at and then linux.engrcs.com. And it'll ask you for your password, and this should be the password that you've recently specified. And then it logs you in, and there you go. Now for me, I can say ssh nick at linux.engrcs.com. It doesn't ask me for my password. Okay, I've set it up so that the server does a handshake with my computer, and it uses that to authenticate that I am who I say I am, and it goes ahead and logs me in. That's really easy to do. Okay, I'm not going to go through the details right now, but do some Googling if you like, and figure out how to do an automatic login for yourself. And if you can't figure it out, let me know. I'll give you a hint though, you do not want to be sending passwords in plain text. So you don't want to write a script that, you know, types out your password to putty or something like that. This is all done through what's called public key encryption. And basically by putting an entry into this authorized keys file, you can set up this handshaking. Alright, so whatever way you choose to log in, whether you type in the password or you set up a shortcut, SSH gets you in there. If you're using putty for now, you can use putty, same thing. Type in your password and you get into a window. There's another video I've posted here, which is ideas for customizing putty. Putty is not Linux. Okay, so let's talk about this for a minute. So what is putty? Putty is not Linux. Putty is not a server. Putty is a program. It's a program which watches your keyboard, and whatever you type, it sends it to another machine. And if that machine sends something back, putty will display that for you. Okay, putty is really a go-between between you and another machine that we call a server. So the typical setup would be something like this. Here's your PC, laptop, Raspberry Pi, whatever. Here's the server. And you want to do some communication back and forth. So on your PC, you're running a program called putty. And putty handles the communication between your PC and the server. But it's just a program. Now, if you say SSH, username at linux.engrcs.com, you're running a different program on your PC. And that program is reading from your keyboard, sending it to the server, and so on and so forth. So for example, if I log into my laptop, right? So on my laptop I'm doing my SSH communication here with the server. If I just open another window and I say, what are all the things that I'm running? Well, you can see I'm running Zoom. I'm running my screen recorder. I'm running my cameras to display my document camera and, you know, this camera. I'm running Chrome. That's my browser. But I'm also running somewhere in here SSH. I'm running a lot of things. Right? So I'm also doing SSH into linux.engrcs.com. right? So putty, SSH, these things are just programs. And if you hate Linux, don't tell people you hate putty. Tell them you hate Linux. If you hate VI, don't tell them you hate Linux or putty. Tell them you hate VI. These are all different things. So I'm running a program, and whatever I type gets sent to the server. The server chooses to send it back to me so I can see what I'm typing, and my program displays that. And if the server wants to tell me something like, hey, I don't know what that command is, it sends that to SSH. SSH displays it here. All right, side note, somebody said, does the specific Linux distro matter? You referenced Xubuntu, which I'm totally on board with, but would any Debian distro work, for example? Yeah, I'm not going to force you into a particular version of Linux. I will tell you that I've been using Xubuntu for a few years, and I've been really happy with it. Because it's pretty low footprint, it doesn't take a lot of resources, and mostly we want to work on the command line. And Xubuntu seems to boot up Linux and get out of your way. It lets you just, bring up a terminal and do what you want. It doesn't have a lot of extra stuff on top. But if you have, a different version that you like, or if you like Mint or something else, that's fine. Linux is more or less Linux, so.
So, does it send every keystroke to the server? So, like, if you just type in J, but you didn't press enter, would that still be going to the server?
Absolutely, because the only reason I'm seeing a J is because the server has sent it back to me.
Oh, okay.
So as soon as you hit something, it goes to the server. All right, so putty, SSH, these things, they're programs. All right, so logging out and logging in. Well, we already know how to log in. We just did that. But let's look at logging out. So if you don't log out and you just leave yourself connected, there's a chance your connection will just disappear. Something will time out, your internet connection will get interrupted or something like that. And sometimes that causes problems. Sometimes your connection disappears, but you don't actually get logged out of the server. You just lose the ability to talk to that session that you had, and so you log in again. And you're limited to, I think I set it to 5 or 9 simultaneous sessions. And then all of a sudden you try to log in and it says some cryptic message like no resources available or something like that. And then you send me an email and we'll figure out what happened and fix it. But there's a couple of ways to log out. So the quickest way is to do Control D. So hold down Control and press D, and it'll say connection closed. And that's a good way to know because Control D is a really useful key combination in Unix. Control D is sort of understood by a lot of programs to mean end of file. Or EOF. When we start talking about doing input in C using fgets and things like that, we'll talk a lot about end of file, and we'll use Control D to signal end of file. But Control D is just one of 128 characters that we can send from our keyboard under what's called an ASCII coding system. So Control D is ASCII character 4. And if we're logged into our server and we type, pwd, it shows me my current directory. If we type ls, it shows me my files in my current directory. If I type Control D, the server says, oh, you want to leave, okay, goodbye, and it closes out the session. So that's one way to exit. Another way to exit is to just say exit. So that'll also log you out. There's other ways you can log out. If I do a PS, I can look at my processes, and I'm running a shell called bash. We'll talk about shells shortly. And the process ID of bash is 15997. If I say kill process 15997, I just killed myself. and my session ended and I logged out. That's not the best way to log out because it doesn't do a lot of cleanup of resources the way typing exit or control D does. But the point is, right, there's nothing magic about processes. They're created, they run, they die. Well, that's pretty magical, actually. All right, so let's talk about shells. So what is a shell? We use a shell in here called bash. Bash is short for the born again shell, which is a play on words because there used to be a shell called SH, which was the born, B-O-U-R-N-E, like born identity shell, which was named, you know, after someone born. And that was SH, and that was one of the earliest shells. And there's C shell, and there's TC shell, and all these cute, you know, word games. But the born again shell, bash, is one of the most popular ones these days. Now these change over time. When I was learning Unix, you know, decades ago, C shell was popular, and so I learned C shell. But bash is around. Bash is popular. Bash is almost always available on a Linux system. It's the shell we're going to use in here. Somebody just asked in chat what the -9 was for here. -9 says, how do I want to kill this process? Okay, and kill is really a needlessly violent word, right? It really should be signal, because when you say kill, you're not actually killing a process. You're sending a message to a process. The message I sent to this process was 9, and message 9 means terminate immediately. So it's kind of like the highest priority, right? It's saying don't, you know, just suggest that the process terminate it right away. But there's other ways that you can signal a process. You can say, you know, terminate, and the process will take that like a control C. And if it feels like it should terminate in response to that, it will. But if not, it might not. So 9 is an absolutely untrappable way to terminate a process, and it's a pretty sloppy way, but it works. All right, so what is a shell? A shell is another program. Everything is a program. A shell is a program that basically takes whatever is sent into it and does something in response and occasionally produces output. Okay, it's a C program. It's written in C. You can download the source code for it. It's a lot of source code, but it's just like a 121 program, right? It uses fgets or something similar to read input from the user. It has a bunch of if statements and loops and things like that, and it uses, you know, printf statements or something similar to produce output. And it will do different things. For example, if I type the word date, it will show me what the current date is. If I type the word date again, it'll show me what the current date is now, and it's the same date, but you know, the number of seconds has changed. Date is not a part of bash. It's not a part of the shell. Date is a program that somebody wrote that's sitting somewhere on my hard drive, or the hard drive of the server. But bash is looking at the words DATE followed by an enter key and saying, let's see if there's a program named date somewhere, and if there is, let's execute it. And it searches, and it does find a program with that name, and it goes ahead and runs it, and whatever that program produces as output, bash displays that for me to see. And remember, bash is sitting on the server along with a bunch of other programs, and so when bash produces output, it gets sent to my laptop and my SSH session, and it displays it on my screen. So there's a lot of layers going on here. So I can say, what is date? And it'll tell me date, parentheses 1, printer set the system date and time. All right, so what's all that about? So there's a series of commands. What is, where is, file, things like that. What is will basically take anything that you can type into bash that bash understands, and it'll tell you something about it. For example, if I say pwd, that shows me /home/nic. What does that mean? Well, that's called my working directory. It's a folder that I'm currently focused on. What is pwd? Print the name of the current working directory. If I want to see the files in this folder, I can say ls. That means list files. If I say what is ls, it gives me two things. List directory contents, that's ls parentheses 1. Uppercase ls6, display animations aimed to correct users who accidentally enter ls instead. Well, what happens if I type uppercase ls instead of lowercase ls? I get this. And that's actually a version of a common typo, which is to transpose two letters. So ls is list files, but if you accidentally swap those and you type sl, right, that's the steam locomotive command, and you get your steam locomotive. All right, it's just a program, but it's a fun program. So yeah, if you accidentally type SL instead of LS, you get to watch the steam locomotive. All right, and we know about that because when we said what is LS, it told us not just about LS, but about this other thing. But what is SL? SL, display animation aimed to correct users who accidentally enter SL instead. So there's a few of these. All right, all of these things that I'm typing in what is, and it's showing me this line of information. You notice there's the thing that I'm asking about followed by a number in parentheses. Okay, so this takes us into our next section, which is about manual pages. So Unix has always had a huge set of online documentation available as part of the operating system. Okay. Now today, you know, if I want to know what time it is, I go to Google, right? I go to Google for everything. But when you're in a Unix environment, you have what are called manual pages. And there's this virtual manual. It's got about 8 chapters to it that describes everything you need to know about Unix as far as commands. Okay, cool. So Scott Koss taught about man pages. Awesome. Yeah, man pages are good. Simple command, just man for manual, space, and the name of the command. So if I want to know what pwd is, I can say man space pwd. And I get this nicely formatted documentation, and it always has the same structure to it. So at the very top is a heading, right, with the name of the command, parentheses, some number. This number is a chapter number. Most of the Unix commands we're going to talk about initially come from Chapter 1. Chapter 1 are the general user commands. Chapter 2 are the low-level functions that you can call that are pretty close to the actual hardware level. We don't do those a whole lot in this course, but in a system programming course, you do a lot of Chapter 2 function calls. Chapter 3 are the function calls like printf, scanf, square root, things like that. Plain old functions that we call from C programs. Chapter 6 is about games. Chapter 8 are about the super user commands, the thing that you use as a system administrator. So creating user accounts, shutting down the system, changing the state of the system, things like that. So pwd is a good old Chapter 1 command, which means anybody can use it, and it's a common Unix command. The name is pwd. There's a one-sentence synopsis, print name of current working directory. The way you run it is you say pwd, and then you can put in optional things after that. Most options on Unix commands start with either a dash or 2 dashes. And the setup is, if you have a 1-character option, you just put a dash in front of it. If you have 2 or more characters, you put 2 dashes. So if I want help on the pwd command, I can say pwd -- help. So let me switch over to my own Linux system here. Pwd -- help, and I get a little bit of information on how to use pwd. But mostly, you know, it's just pwd with no options on it. If no option is specified, -p is assumed, which says print out what's called the physical way, physical path. And your shell may have your own version of pwd. It may be a built-in command. When you're looking at man pages, when you get to the bottom, you get this highlighted bar here, which says we're in man page pwd1, line 4, press H for help, Q to quit. You can also hit a space bar to go on to the next page, or you can hit enter to go down one line. So I can see who wrote it. If I hit a space bar, I'll go down and see the next page of this. It tells you how to report bugs, copyright information. See also, and I can hit another space bar. So now I'm at line 23 out of 48. Hit another space bar, and so this is line 23 up here. So I'm at the end of my manual page. Okay, it says end. So now if I want to get out of here, I just type a Q. And then I come back to my own page. So somebody asked, is there a way to just navigate through the man pages to each chapter? So if we look at the manual page for the manual page command, it's a much longer page. It has many more options. But these pages always have the same basic structure. There's a name, there's a synopsis which shows you all the options you can use. There's a description of the command which is more detailed. And examples. I don't know what the difference is between overview. But then a section on options, and this is usually the longest section. And that'll show you everything that's available. And I can scroll with my mouse wheel. Because it's not an entirely archaic system. And if you get down close to the bottom, you find a section called Files. And Files will tell you any files on the system related to this. And we can use this to start sleuthing out how some of these things work. So user share man, a global manual page hierarchy. And then see also things that are related, history, and so on and so forth. So let's go into user share man and let's take a look. And in this directory, so CD is changing my working directory. And in that directory, user share man, if I say ls, I find directories in there called man1, man2, man3, man4, and so on. If I list man1, guess what? These are all the chapter 1 manual pages. So that's one way to get kind of a list of all the basic Unix commands that are available to the general user, and you can see there's quite a few of them, including things like bracket and 2 to 3 and make and man and mock and so on and so forth. So that's one way to see a list of all the commands that are available. Alright, so the main thing to remember about manual pages is if you want to get out of here at some point, just hit a Q. If you want to see the next page, use the space bar. If you want to just go down a few lines, use the enter key. And if you have a mouse with a wheel and you're on a good system, chances are you can probably just scroll back and forth using the mouse wheel. And that's handy. Alright, one problem with this kind of setup is if you don't know the name of the command you're looking for, you can't find the manual page for it. Right? It's the dictionary problem. You're trying to spell a word using the dictionary. Well, you got to know how to spell it in order to look it up. So, so there's a keyword option you can use with the man command. So suppose I want to know how to compile a C program, but I can't remember the name of the command. Right? You can say man-keyword and put in something that you think might be in the description of the command you're looking for. For example, I'm looking for how to compile a C program. So I'm going to say man-k compile. And I get a whole bunch of commands related to compiling, and right here is GCC, GNU Project C and C++ compiler. But I also got C++, the C++ compiler, I got C89, I got plain old CC, I got Python, and all kinds of things like that. I got Java C, which is the Java compiler, right? But that's one way to sort of find a command you're looking for if you can't remember the name of it. Another one would be to go search through that directory, user share man, and search for a file with that name. But man-k usually works pretty well. Alright, so with the manual pages and with a bash shell, you can start doing a lot of exploring. And especially if you're running in something like a VirtualBox environment, it's hard to get into trouble. Right? If you accidentally delete all of your files, you're doing it on a synthetic hard drive, a virtual hard drive, and maybe you have to reinstall your Linux setup in VirtualBox, but you haven't actually done any harm, right? Unless you're writing your project for class and you delete that file too. But in the beginning, when you're playing around, you're exploring and experimenting, right? It's a nice sort of sandbox environment that you can mess with freely without too much danger to critical stuff. All right. And if questions come up along the way, let me know. Why do so many commands seemingly do the same thing, such as the C compilers? Why are there so many editors? Because there's no one size fits all. So C compilers, there's CC, which was the original C compiler, at least when I started doing C like 40 some years ago. CC was how you did C compilation. GNU CC, so GNU is an acronym which stands for GNU is not Unix, GNU. It's an implementation of a bunch of Unix commands done in a free, open way. Unix was originally a commercial product from AT&T, pretty expensive, very expensive to get source code for, so it was proprietary. And then GNU opened up a lot of this stuff, made freely available public domain versions of these commands. So GCC is the GNU C compiler, Gawk is the GNU version of awk, Gmake is the GNU version of make, and so on. C++ was the original C++ compiler. C89 was the original version of the C compiler built around the standards, agreed upon in around 1989 for standardizing the language more completely. And these things are available for legacy reasons, but chances are that C++ is just a link to GCC or G++. But one of the nice things about Linux is, yeah, it changes, it evolves and develops over time, but things usually don't break, right? I have code that I wrote 25 years ago that does graphical interactions and interacts with my mouse and shows things on a display and so on. I can put that code on my laptop today in 2020, compile it and run it, and it works. There's a pretty good awareness that things should not break over time, that things that ran last year or last decade should still run, and so you'll find references under old names to commands that have newer versions, but we can still refer to them the old way. Yeah, lots of recursive acronyms too, like GNU. And lots of really short commands like ls is how you show the files in your directory. I think there was a mindset when this was being developed in the 70s of trying to keep the commands as short as possible. Not to make them cryptic, but to make it so you didn't have to type too much stuff. And ls, 2 characters, it's about as short as you can get. A 1-character command, you don't have too many of those, right? You got 26 letters. But 2 characters, yeah, you got a fair number. And the majority of commands are, 2, 3, maybe 4 characters, but a lot of 2 or 3 character commands. All right. All right, moving around the file system. So there's a hierarchy of files in Linux, like most operating systems. Starting with what's called the root directory, which is slash. That's sort of the top level of the whole hierarchy of files. And there's a number of directories underneath this root. There's slash usr that we already looked at, user share. There's slash home, which is where all of our login directories exist. There's slash etc, which is where a lot of system files and directories exist. And there's other things in here as well. So we can use the command cd to change our current directory. So if I say cd slash, and then I say print my current directory, it tells me my current directory is slash. So cd and pwd go together. And if I say ls, it'll show me what's in my directory slash my root directory. Well, there's usr, there's home, there's etc, and there's also dev, and there's backup and temp and a few other directories. And some of these things are files, some of them are directories. So if I say ls and I put the switch -l, I get more information about each of these entries. Anything that starts with a D is a directory. So lib, lib64, lost and found, those are directories. Anything that doesn't start with a D, anything that starts with a dash here in column 1 is a file. So swap file is a file. Most of these other things are directories. If you start with an L, that's what's called a link. It means that this thing is really referring to something else in my file system. So main data actually refers to a file /media/nic/main data. That's an external drive I use. So ls shows you your list of files. ls-l shows you your list of files with more details. So we have directories under here. If I change my directory to /home and I say list, I can see 6 entries in here. And if I look at those, they're all directories. So these would all be users on my system. And so yeah, someone pointed out you can usually do LL, that's an abbreviation for ls-l. So that does an ls-l. And this will start to get into one of the themes we're going to talk about a lot this week, which is customizing your environment. If you type ls-l a lot and you don't like typing 5 characters, you can set up something like LL to be an abbreviation for ls-l. And it's what's called an alias. LL is the same as typing ls-al uppercase F. So L is the long listing, A is saying show me all my files including things that start with a dot, and so on. Alright, so if I change my directory to /home/nic, that's my login directory. And that has all of my stuff in it. And most of my stuff are directories that contain other things. Alright, so cd changes your directory, pwd shows you your current directory. And I can also, instead of saying cd/home/nic/something, if I want to go into another directory, like useful commands, I can just type cd useful commands, and that says go into the subdirectory, go into the directory underneath where I currently am, called useful commands, and show me what's in there. And if I go from there into my teaching directory, right, now I'm in /home/nic/useful commands/teaching. But instead of typing cd all of this stuff, I was already sitting in here, and I just said cd teaching, Now I'm going down one level into my teaching directory. If I want to go back to my login directory, I can just say cd. And cd with no arguments takes you to your home directory, the directory that you're in when you first log in. It should. You can also cd to a tilde, and that means take me to my home directory. And you can also cd tilde and a username, and it'll take you to that username's home directory. So if I do cd tilde test, that'll take me to /home/test. Alright, someone asked, what if you just want to go up one level in your directory? So here I am down in Files, Useful Commands, Teaching, QA. I can cd ... and that moves you up one level. So now I'm in Teaching. If I cd ... again, that'll move me up one level to my Useful Commands directory. If I do one more, that'll move me to Files. If I do ... again, that'll move me to /home/Nick. If I move ... that'll move me all the way up to /home. If I'm sitting in my /home/Nick, I can say move up one level and then move down to Barbara. And so I've moved up, over, and down. And there's all kinds of things you can do with this, right? And if I move up a whole bunch so that I'm sitting in the root directory and I try to move up one level, I just stay in the root directory. So you can't go above that top level. Alright, so let me make one philosophical observation here. And this will come back again and again. Linux is this huge, gargantuan, tens of thousands of commands, and each command has, dozens of switches and things like that. The amount of Unix that I use after 40-some years is about this much. Okay? It's a tiny little subset. But it's a particular subset that I've been using for all this time and that I understand really well, and that works great for me. And for each person, you'll have your own subset of commands and ways of interacting with the environment that work well for you. So you do not need to go home and memorize, what does cd ... /Barbara mean, right? All you really need to get around is cd and pwd. And if I want to get to, /home/Barbara, I can always say cd /home/Barbara, and that'll get me there. And if I want to know that that's where I am, I can say pwd. But if you find yourself doing things like wanting to move up and over and down a lot, right? At some point you'll come back and you'll experiment when you have some time and discover, oh, I can say cd ... to move up, / and then another name to move down, and that moves me horizontally across, right? If that doesn't click for you, don't worry about it. Unix is very much about figuring out what wants to go in your toolkit, right? And because it's a class, there's some things I'm going to require you to learn. I'm going to require you to learn VI and awk and sed and things like that. And you'll see things on tests about, if I do cd ... where does that go? But beyond the class, outside of the class, right, your vision of Unix will be your own. And you want to be open to discovering that and finding things that work, and adopting new things when they come up, and letting go of old things when you find you don't use them very much, and so on. And I think that's sort of one key to having a successful time working in this environment. All right, so that's it for our time today. So we'll keep going with this. We'll talk about tricks for working on the command line, recalling commands, editing commands, and so on. Then we'll start digging into some more specific commands and we'll go from there. Make sure you've logged into the server, done your homework, do 8 o'clock tomorrow morning. Log in, run the answer program, tell me your favorite color, and then send me an email message with anything in it you like using the mail command on Linux. All right, thanks. I will see you next time.